September 6, 1976. The defection of Viktor Belenko and the problem that was killing Soviet pilots. At 13 minutes past 1 in the afternoon on September 6, 1976, Senior Lieutenant Viktor Belenko pushed his Mikoyan Gurevich MiG-25 Foxbat into a hardbank over the Sea of Japan and pointed the nose toward Hokkaido. He was 29 years old. He had been planning this moment for 2 years. Behind him, 2 other MiG-25 fighters from his squadron were scrambling to intercept. They had exactly 4 minutes before he crossed into Japanese airspace and became untouchable. Belenko did not look back. He dropped to 6,000 meters, leveled the aircraft, and opened the throttles. The twin Tumansky engines screamed. The airspeed indicator climbed past Mach 2. In the cockpit, the temperature rose to 50 degrees Celsius. His flight suit was soaked through. The fuel gauge showed less than 8 minutes of flying time remaining. He had lied to his ground crew that morning, told them he needed extra fuel for a training exercise. They had believed him. Now that lie was the only thing keeping him alive. At 7:40 in the morning Tokyo time, Japanese air defense radars picked up an unidentified aircraft traveling at extremely high speed toward Hokkaido. 2 F-4 Phantom fighters were scrambled from Chitose Air Base. By the time they reached altitude, Belenko had already descended below radar coverage. He was flying on instinct now, using visual navigation, following the coastline. His intended target was the American Air Base at Chitose. But the fuel was almost gone. The red warning light on the instrument panel was flashing. He had maybe 2 minutes left. Below him, he saw a runway. Hakodate Airport, a civilian airfield. Not American, not military, but it would have to do. He dropped the landing gear. The MiG-25 weighed 20 tons fully loaded. The runway at Hakodate was 2,100 meters long. A MiG-25 needed at least 2,500 meters to stop safely. Belenko did not care. He slammed the aircraft down onto the concrete at 280 kilometers per hour. The tires exploded on impact. The brakes locked. The MiG-25 skidded off the end of the runway, tore through a fence, and came to rest 40 meters from a busy highway. Drivers stopped their cars. Some of them grabbed cameras. Belenko climbed out of the cockpit, pulled his service pistol, and fired 2 shots into the air to keep people back. Then he walked toward the terminal building and said in broken English that he wanted to go to the United States. Within 3 hours, the Soviet Union had sent a formal diplomatic protest to the Japanese government, demanding the immediate return of the aircraft and the pilot. Within 6 hours, the United States Central Intelligence Agency had sent a team of engineers and translators to Hakodate. Within 12 hours, the Japanese Ministry of Justice had granted Viktor Belenko temporary asylum pending transfer to American custody. Within 24 hours, the Director of Central Intelligence, George H.W. Bush, had called the defection an intelligence bonanza and authorized a complete technical examination of the MiG-25. The Soviets were furious. They claimed Belenko had been drugged by the Japanese. They claimed he had gotten lost during a training flight. They seized Japanese fishing vessels in retaliation. None of it mattered. On September 9, 1976, Viktor Belenko boarded a Northwest Orient Airlines flight to the United States. He would never return to the Soviet Union. The MiG-25 was disassembled piece by American and Japanese engineers, examined for 2 weeks, and then returned to the Soviets in crates. By then, every dimension, every component, every system had been measured, photographed, and analyzed. What the Americans found shocked them. The MiG-25 was not the superfighter they had feared for the past decade. It was fast, yes. It could fly at Mach 2.8. In short bursts, it could reach Mach 3.2. But the engines would be destroyed if it flew that fast for more than a few minutes. The airframe was made of nickel steel, not titanium like American fighters. It weighed twice as much as an F-15 Eagle. The avionics were primitive. The radar used vacuum tubes instead of transistors. The aircraft had almost no maneuverability at high speeds. It could not turn. It could not dogfight. It was a pure interceptor, designed to fly straight at enemy bombers and fire long-range missiles. And it had a flaw. A serious, dangerous, fatal flaw that had been killing Soviet pilots since the aircraft entered service in 1970. The flaw was in the flight control system. Specifically, in the way the aircraft handled negative G-forces during high-speed dives. At 3 in the afternoon on September 7, 1976, while American engineers were still crawling over Belenko's MiG-25 in Hakodate, a man named Anatoly Krylov sat in a windowless office on the 4th floor of the Mikoyan Design Bureau in Moscow and read a classified cable from the Soviet embassy in Tokyo. Krylov was 51 years old. He had worked for the Mikoyan Design Bureau for 26 years. He was the chief engineer responsible for flight control systems on the MiG-25. He had designed the hydraulic actuators that controlled the elevators and ailerons. He had personally tested the control laws that governed pitch and roll stability. He knew the MiG-25 better than anyone alive except maybe Rostislav Belyakov, the chief designer. And he knew the secret that the cable from Tokyo was about to expose to the Americans. The MiG-25 had a problem with negative G maneuvers. When a pilot pushed the control stick forward to enter a dive, especially at high speeds, the fuel in the main tanks would slosh forward and uncover the fuel pump intakes. The engines would surge. Sometimes they would flame out completely. The pilot would lose power in the middle of a combat maneuver. If he was lucky, he could restart the engines. If he was not lucky, he would have to eject. If he was very unlucky, he would not have time to do either. Krylov had known about this problem since 1971. So had everyone else at the Mikoyan Design Bureau. They had tried to fix it. They had installed baffles in the fuel tanks to prevent sloshing. They had modified the fuel pump design. They had changed the control laws to limit the rate of pitch change. Nothing worked. The problem was fundamental. It was not a design error. It was a design compromise. The MiG-25 had been designed to intercept high-altitude bombers, not to dogfight. It was not supposed to pull negative G maneuvers. Soviet pilots were trained to avoid them. But in combat, pilots did what they had to do. And in combat, 47 MiG-25 pilots had died because of fuel starvation during negative G maneuvers between 1970 and 1976. That number was classified. It did not appear in any official records. It was not discussed outside the Design Bureau and the Ministry of Aviation Industry. Families of dead pilots were told their sons or husbands had died in training accidents or mechanical failures. The truth was considered a state secret. The truth was that the Soviet Union's most advanced interceptor had a flaw that made it dangerous to fly in combat. And now, thanks to Viktor Belenko, the Americans were going to discover that flaw. They were going to examine the fuel system. They were going to test the flight controls. They were going to figure out exactly why MiG-25 pilots kept dying. And then they were going to use that knowledge against Soviet pilots in future air combat. Krylov put the cable down on his desk. He looked at the technical drawings pinned to the wall of his office. schematics of hydraulic systems, graphs of fuel flow rates, test data from wind tunnel experiments, 26 years of work, thousands of hours of design and testing, and a flaw he had never been able to fix. He reached for the telephone and dialed the number for General Pavel Kutakov, Commander-in-Chief of the Soviet Air Forces. The call was answered on the second ring. Krylov identified himself and said he needed to speak to the general immediately about the Belenko defection. There was a pause. Then the voice on the other end of the line told him the general would see him at 8 that evening at Air Force headquarters. Krylov hung up. He had 5 hours to prepare a briefing that would explain why 47 Soviet pilots had died flying an aircraft he had helped design, and what he planned to do to make sure no more pilots died the same way. At 8 that evening, Krylov stood in front of a conference table in a secure room at Soviet Air Force headquarters and faced 7 men. General Kutakov sat in the center. To his left were 2 deputy commanders and a representative from the Ministry of Defense. To his right were 2 colonels from the Air Force Scientific Research Institute and a man Krylov did not recognize wearing a civilian suit. No one introduced the man in the suit. Krylov understood what that meant. KGB. He set his briefcase on the table, opened it, and pulled out a folder containing graphs and technical drawings. He placed the first document on the table. It was a chart showing MiG-25 accident rates by year, from 1970 to 1976. The line climbed steadily upward. Krylov pointed to the numbers and said that 47 pilots had died in MiG-25 crashes caused by fuel starvation during negative G maneuvers. General Kutakov leaned forward and asked how many of those deaths could have been prevented. Krylov said all of them. The room went silent. One of the colonels from the Scientific Research Institute asked if the Americans would discover the flaw when they examined Belenko's aircraft. Krylov said yes. It was inevitable. The fuel system design was obvious. Any competent engineer would see the problem immediately. The man in the civilian suit asked if the flaw could be fixed. Krylov said yes, but not with Soviet technology. The solution required a completely different approach to fuel management. The Soviets did not have that technology, but the Americans did. The man in the suit asked how Krylov knew that. Krylov placed another document on the table. It was a translated excerpt from an American aviation journal describing the fuel system of the F-15 Eagle. The article had been published in 1974. It described a system that used computer-controlled pumps and valves to maintain continuous fuel flow regardless of G forces. Krylov said the F-15 could pull negative G maneuvers at any speed without fuel starvation. The MiG-25 could not. The difference was in the system design. General Kutakov asked if it was possible to acquire detailed technical information about the F-15 fuel system. Krylov said he did not know. That was not his area. The man in the civilian suit said it might be possible. He did not elaborate. Kutakov looked at Krylov and asked how long it would take to implement a similar system in the MiG-25 if detailed technical information became available. Krylov said 6 months for design, 3 months for prototype testing, another 6 months for production implementation. Total time, 15 months. Kutakov nodded. He told Krylov to prepare a detailed technical specification of what information would be needed from the F-15 to solve the MiG-25 fuel starvation problem. He told him to have the specification ready in 48 hours. Then he told him to go home and not discuss this meeting with anyone. Krylov gathered his documents, put them back in his briefcase, and left the room. He took the metro back to his apartment in southwest Moscow. It was past midnight when he arrived. His wife was asleep. He went into his study, turned on the desk lamp, and opened his briefcase. He pulled out a blank notebook and started writing. He wrote down every detail he could remember about the F-15 fuel system from the article he had read. He wrote down calculations for fuel flow rates and pump capacities. He wrote down questions he would need answered to design a similar system for the MiG-25. He filled 23 pages. At 4 o'clock in the morning, he stopped writing and looked at what he had produced. It was a specification for stealing American technology. He wondered if he would be arrested for writing it. Then he wondered if he would be arrested for not writing it. Then he stopped wondering and went to bed. 2 days later, he delivered the specification to General Kutakov. 3 days after that, the man in the civilian suit visited Krylov at his office and told him to apply for an international travel passport. When Krylov asked why, the man said he could not say yet. When Krylov asked where he would be traveling, the man said he could not say that either. Then the man left. On September 25, 1976, 19 days after Viktor Belenko landed at Hakodate, Anatoly Krylov received a telephone call at home. The voice on the line told him to pack a bag for 1 week, bring his passport, and report to Sheremetyevo Airport at 6:00 the next morning. The voice gave him a flight number and told him not to tell anyone where he was going. Then the line went dead. Krylov did not sleep that night. At 5 in the morning, he kissed his wife goodbye and told her he was going on a business trip. She asked where. He said he did not know. She did not ask again. At 6:00, he presented his passport at Sheremetyevo Airport and was escorted to a departure gate by 2 men in suits. At 8:00, he boarded an Aeroflot flight. The destination board said Tehran. Chapter 2. The Secret Operation. 72 Hours to Study. The F-15 Eagle. The Aeroflot Ilyushin 62 touched down at Mehrabad International Airport in Tehran at 2:15 in the afternoon local time. The temperature outside was 38 degrees Celsius. Anatoly Krylov looked out the window and saw heat waves shimmering off the concrete. He had never been to Iran. He had never been outside the Soviet Union, except for one trip to East Germany in 1968. Now he was standing on the tarmac in a country that was technically neutral, but leaning toward the West, carrying a briefcase full of technical specifications, with no idea why he had been sent here or what he was supposed to do. A man in a dark suit was waiting at the bottom of the stairs. He did not introduce himself. He took Krylov's passport, examined it, handed it back, and said in Russian to follow him. They walked across the tarmac to a black Mercedes sedan with diplomatic plates. The man opened the rear door. Krylov got in. The car drove away from the terminal without going through customs. They drove for 40 minutes through Tehran traffic. Krylov watched the city pass by outside the window. Crowds of people, markets, mosques, modern buildings next to ancient structures. Everywhere, portraits of the Shah, Mohammad Reza Pahlavi, the King of Kings, Light of the Aryans. Krylov had read about him in Pravda. The articles always described him as a puppet of American imperialism. But the Shah had also bought weapons from the Soviet Union, helicopters, anti-aircraft missiles. The relationship was complicated. Finally, the Mercedes turned into a gated compound in the northern part of the city and stopped in front of a 3-story building with no signs or markings. The man in the suit told Krylov to get out. They went inside. The interior was cold, air conditioning, a luxury Krylov was not used to. They walked down a corridor and entered an office where another man was waiting. This man was older, maybe 60, with gray hair and a face that showed no emotion. He spoke Russian with a Moscow accent. He told Krylov to sit down. The man did not waste time. He said that Krylov had been brought to Tehran because the Soviet Union had an opportunity that would only exist for the next 3 days. The opportunity involved an F-15 Eagle fighter aircraft. Krylov felt his heart rate increase. The man continued. He said that the Imperial Iranian Air Force had purchased 80 F-14 Tomcat fighters from the United States in 1974. The first aircraft had been delivered in January 1976. The Iranians had also expressed interest in purchasing F-15 Eagles, and the Americans had agreed to provide a demonstration aircraft for evaluation. That aircraft had arrived in Tehran 5 days ago. It was currently at Mehrabad Air Base undergoing inspection by Iranian pilots and technicians. American instructors were scheduled to arrive on September 29th to begin training flights. That gave the Soviet Union exactly 72 hours to examine the aircraft before American personnel took control of it. The question was whether Krylov could extract the technical information needed to solve the MiG-25 fuel starvation problem in 72 hours. Krylov asked how he was supposed to gain access to an American fighter aircraft on an Iranian military base. The man said that had already been arranged. Krylov would be traveling under Iranian documents as a technical advisor from the Iranian Ministry of War. The Iranians did not know he was Soviet. They thought he was one of their own people. Someone had been paid. Someone always could be paid. Krylov asked what would happen if he was discovered. The man said he would be arrested by Iranian security, turned over to the Americans, and probably spend the rest of his life in prison. The Soviet Union would deny any knowledge of him. His family would be told he had died in an industrial accident. Then the man opened a drawer in his desk, pulled out a leather document holder, and slid it across the table to Krylov. Inside was an Iranian passport with Krylov's photograph and a different name. Krylov stared at the photograph. It had been taken without his knowledge, probably during one of his meetings at the design bureau. Someone had been following him. Someone had been preparing this operation for weeks, or maybe months. The man asked if Krylov understood what was being asked of him. Krylov said yes. The man said good. Then he handed Krylov a briefcase. Inside were a camera, 12 rolls of film, a measuring tape, a notebook, and a set of technical drawings showing the general layout of the F-15. Krylov recognized the drawings. They were based on publicly available information from American aviation journals. They were incomplete. They were approximations. His job was to fill in the gaps. His job was to photograph every component of the fuel system, measure every dimension, document every valve and pump and sensor, and figure out how the Americans had solved a problem that Soviet engineers had failed to solve for 6 years. At 6 that evening, Krylov was driven to a small apartment in central Tehran. He was told to stay inside until morning. He was told not to leave for any reason. A guard would be posted outside the door. Food would be brought to him. He was given a uniform of the Imperial Iranian Air Force with the rank insignia of a technical major. He was given a laminated identification card with his photograph and his false name. He was told to memorize the details on the card: date of birth, place of birth, service history. He spent the night sitting at a small table under a ceiling fan that did not work, repeating the information over and over until he could recite it without thinking. He did not sleep. His hands were shaking. He kept thinking about what the man in the office had said. "If you are discovered, we will deny any knowledge of you. Your family will be told you died in an industrial accident." He thought about his wife. He thought about his daughter, who was studying chemistry at Moscow State University. He thought about the 47 dead pilots whose names he had memorized from classified accident reports. He thought about the MiG-25 and the flaw he had never been able to fix. At 4 o'clock in the morning, he stopped thinking and started preparing. At 7 hours, a different man arrived at the apartment. This one spoke Farsi. He told Krylov in broken Russian to put on the uniform and follow him. They drove to Mehrabad Air Base in morning traffic. The sun was already brutal. Krylov was sweating through the uniform before they reached the gate. The guard at the gate examined his identification card, waved them through. They drove past rows of F-4 Phantom fighters, past maintenance hangars, past fuel trucks and ammunition bunkers, until they reached an isolated section of the base surrounded by a chain-link fence topped with barbed wire. Inside the fence sat the F-15 Eagle. Krylov had seen photographs. He had studied technical drawings. But seeing the aircraft in person was different. It was larger than he expected. The twin vertical stabilizers rose 7 meters into the air. The nose was sharp and aggressive. The cockpit canopy was frameless, offering the pilot an unobstructed view. The aircraft was painted in standard United States Air Force gray, with the markings removed. Someone had tried to make it look neutral. It did not work. This was an American fighter. This was the aircraft that would replace the F-4 Phantom as the primary air superiority fighter of the United States Air Force. This was the aircraft that Soviet pilots would face in combat, if war ever came. And Krylov had 72 hours to learn everything about it. 2 Iranian technicians were already working on the aircraft when Krylov arrived. They were young, maybe mid-20s, both trained in the United States. They spoke English to each other. Krylov introduced himself using his false name and said he had been sent by the Ministry of War to conduct an independent evaluation of the fuel system. The technicians looked at him with suspicion. Krylov understood. They had not been told anyone else would be joining them. He showed them his identification card and a letter of authorization with an official seal. The letter was a forgery, but a good one. The technicians examined the letter, shrugged, and went back to their work. Krylov opened his briefcase and pulled out the technical drawings. He asked the technicians if they could show him where the fuel tanks were located. One of them pointed to the wings and the center fuselage. Krylov nodded. He asked if he could access the fuel system components. The technician said yes, but they would need to remove several access panels first. Krylov said that was fine. He would wait. The technician asked why the Ministry of War was interested in the fuel system. Krylov said he did not know. He had been told to document everything and write a report. The technician laughed and said that sounded like the military. They started removing access panels. By 10 WEAV that morning, Krylov had photographed the fuel tank layout from 6 different angles. By noon, he had documented the pump locations and the valve configuration. By 2 hours in the afternoon, he had measured the diameter of every fuel line visible in the center fuselage section. The technicians mostly ignored him. They were busy running their own tests, checking hydraulic pressure, examining the control surfaces. Krylov worked methodically. He moved from one system to another, taking photographs, making measurements, writing notes in his notebook. The heat inside the fuselage was unbearable. The temperature exceeded 50 degrees. His uniform was drenched with sweat. His hands were slippery. He dropped the camera twice. The second time, the lens cap fell off and rolled under the aircraft. He had to crawl on his stomach in the dirt to retrieve it. One of the technicians asked if he was all right. Krylov said yes. He was fine, just not used to the heat. The technician offered him water. Krylov accepted. They sat in the shade under the wing and drank from plastic bottles. The technician asked where Krylov had trained. Krylov said he had studied engineering at Tehran University and then worked in military logistics. The lie came easily. He had practiced it 100 times during the night. The technician nodded and did not ask more questions. At 5 in the afternoon, one of the technicians told Krylov they were finished for the day. The base closed to non-essential personnel at 6 Giri. Krylov asked if he could return tomorrow. The technician said yes, but he would need to check in with the security officer each morning. Krylov said that was fine. He packed his briefcase, walked back to the car that was waiting for him, and returned to the apartment in central Tehran. The man who had driven him was waiting inside. He asked if Krylov had obtained useful information. Krylov said yes, but he needed more time. He had documented the fuel tank layout and the basic pump configuration, but he had not yet found the critical components. The computer-controlled valves, the fuel flow sensors, the pressure regulation system. Those were the pieces that made the F-15 fuel system work under negative G-forces. Those were the pieces he needed to copy. The man said he had 2 more days. Krylov said he understood. Then he developed the film in a makeshift darkroom that had been set up in the bathroom, examined the photographs under a lamp, and started writing technical notes. He worked until midnight. Then he lay down on the bed without undressing and closed his eyes. Sleep did not come. His mind kept replaying the day, the heat, the aircraft, the technicians, the lies. He wondered if they suspected anything. He wondered if someone was watching him. He wondered if the next morning would be his last day of freedom. The second day was harder. Krylov arrived at the base at 7 and immediately requested permission to examine the fuel control unit mounted in the forward equipment bay. The technician said that section was sealed and would require special authorization to open. Krylov showed them the forged letter again and said his instructions were to examine all aspects of the fuel system. The technicians looked at each other. One of them said he would need to call his supervisor. Krylov felt his stomach tighten. This was the moment he had been dreading. If the supervisor asked too many questions, if someone checked his credentials too carefully, the operation would collapse. He forced himself to remain calm. He said that was fine. He would wait. The technician walked to a field telephone mounted on a nearby post and made the call. The conversation lasted 3 minutes. Krylov counted every second. Finally, the technician hung up and walked back. He said his supervisor had approved the request, but Krylov would need to sign a log documenting everything he accessed. Krylov signed the log. His hand was steady. Inside, his heart was hammering against his ribs. The fuel control unit was a masterpiece of American engineering. It was a rectangular box approximately 40 centimeters long, 25 centimeters wide, and 15 centimeters deep, mounted on a shock-absorbing frame. Inside were dozens of circuit boards, pressure sensors, solenoid valves, and a small computer processor. Krylov had never seen anything like it. Soviet aircraft used mechanical fuel controls, analog systems, pumps and valves operated by cables and hydraulic pressure. The F-15 used a digital system. The computer monitored fuel pressure, flow rate, and G-forces in real time and adjusted the pump speeds and valve positions to maintain continuous fuel flow regardless of aircraft attitude. It was brilliant. It was exactly what the MiG-25 needed. And it was technology the Soviet Union did not have. Krylov photographed every angle of the unit. He traced the wiring harnesses. He documented the sensor locations. He spent 4 hours on that single component. The technicians came by twice to check on him. Both times, Krylov was bent over the unit with a magnifying glass, examining connection points. They asked what he was looking for. He said he was documenting the maintenance access points for the Ministry of War Technical Manual. They accepted the explanation and left him alone. By the end of the second day, Krylov had photographed 400 separate images and filled 80 pages of technical notes. He had documented the complete fuel system layout, the pump specifications, the valve configurations, and most importantly, the computer control unit that made the entire system work. He returned to the apartment, developed the second batch of film, and spent the night organizing the information. The man who had briefed him on the first day arrived at midnight. He examined the photographs and the notes. He asked if Krylov had everything he needed. Krylov said almost. There was one more component he had to document: the G-force sensor that fed data to the fuel control computer. He had seen it mounted on the bulkhead behind the pilot's seat, but he had not been able to access it. He would need the third day to photograph it and trace its wiring. The man asked if that component was critical. Krylov said yes. Without understanding how the G-force sensor worked, Soviet engineers would not be able to replicate the system. The man said then Krylov would have to get it tomorrow. There would be no fourth day. American instructors were arriving tomorrow evening. This was the last chance. The third day, Krylov arrived at the base at 6:30, before the technicians. He went directly to the F-15, climbed into the cockpit, and started examining the area behind the ejection seat. The G-force sensor was there, exactly where he expected it to be. It was a small cylindrical device mounted on a bracket, with 4 wires running to a junction box. Krylov pulled out his camera. The light inside the cockpit was poor. He adjusted the aperture, braced his arms against the cockpit frame to steady the camera, and started taking photographs. He took 12 shots from different angles, then he climbed out of the cockpit and moved to the junction box to trace the wiring. That was when he heard the voice behind him. It was speaking English. American English. Krylov turned around. A man in a United States Air Force uniform was standing 10 meters away, talking to one of the Iranian technicians. The technician was pointing toward the F-15, toward Krylov. The American officer started walking toward the aircraft. Krylov felt ice water dump into his veins. The Americans were not supposed to arrive until evening. Someone had changed the schedule. He was out of time. Krylov forced himself to move slowly. Panic would give him away. He closed the junction box cover, picked up his briefcase, and climbed down from the access ladder as if he had finished a routine inspection. The American officer was 30 meters away now, walking directly toward him. Krylov could see his rank insignia. Major, United States Air Force. The Iranian technician was walking beside him, gesturing toward the aircraft, explaining something. Krylov's mind raced through options. He could run. That would guarantee his arrest. He could try to bluff his way through a conversation. That would fail the moment the American asked a technical question he could not answer in proper Farsi. He could pretend not to speak English. That might work for a few minutes, but the major would call for a translator, and then the questions would start. There was no good option. He was trapped. He picked up his briefcase and started walking toward the perimeter fence, away from the aircraft, trying to look casual. The Iranian technician called out to him in Farsi. Krylov did not understand Farsi. He kept walking. The technician called out again, louder this time. Krylov stopped. He turned around. The American major was standing next to the F-15 now, looking at him. The technician jogged over. He asked Krylov in Farsi where he was going. Krylov understood the tone, if not the words. He responded in Russian without thinking, said he was finished for the day. The technician's face changed. Confusion, then suspicion. He asked Krylov something else in Farsi. Krylov realized his mistake. He switched to broken English and said he did not speak Farsi well. He was from Tabriz. They spoke Azeri there. He usually worked in logistics, not on the flight line. The lie was clumsy. The technician stared at him. Then he turned and called to the American major. The major walked over. He looked at Krylov's uniform, at his identification badge, at the briefcase. He asked in English who Krylov was and what he was doing with the aircraft. Krylov said he was conducting a technical evaluation for the Ministry of War. The major asked what kind of evaluation. Krylov said fuel system documentation. The major asked if he was part of the Iranian evaluation team. Krylov said yes. The major asked why he had not been informed that additional personnel would be accessing the aircraft. Krylov said he did not know. He had authorization from his supervisor. The major asked to see the authorization. Krylov pulled out the forged letter. The major examined it. His expression did not change. He handed the letter back and said he would need to verify this with his Iranian counterparts. He asked Krylov to wait. Then he walked toward the field telephone. Krylov stood in the sun and watched the major make the call. His shirt was soaked through. His hands were trembling. He gripped the briefcase tighter to hide it. Inside the briefcase were 12 rolls of exposed film documenting every critical component of the F-15 fuel system. If the Americans searched him, if they developed those films, the entire operation would be exposed. He would be arrested. His family would never know what happened to him. The 47 dead MiG-25 pilots would remain unavenged. The flaw would never be fixed. More pilots would die. He thought about running again. The fence was 20 meters away. Beyond the fence was the civilian side of the airport. If he could reach it, if he could disappear into Tehran, maybe the Soviet handlers could extract him. But the Iranian guards at the gate had automatic rifles. He would not make it 10 meters. The major finished his call and walked back. His face was hard. He said there was a problem. The Ministry of War had no record of anyone named on Krylov's identification badge being assigned to this evaluation. The authorization letter appeared to be fraudulent. He was placing Krylov under military detention pending investigation. He told the Iranian technician to call security. Krylov felt the world narrow to a single point. This was the end. 26 years of engineering, 51 years of life. It would all end here on a hot tarmac in Tehran, arrested as a spy. His wife told he had died in an industrial accident, his name erased from history. He looked at the American major and made a decision. He said he needed to tell the major something important. The major asked, "What?" Krylov said, "Not here. Somewhere private. It was a matter of aircraft safety." The major looked skeptical. He asked what kind of safety matter. Krylov said the F-15 had a design flaw in the fuel system that could cause engine failure during negative G maneuvers. The Major's expression changed. He asked how Krylov knew that. Krylov said because he had seen the same flaw kill pilots in other aircraft. The Major studied Krylov's face for a long moment. Then he told the technician to delay the security call. He took Krylov by the arm and walked him to a maintenance office at the edge of the flight line. He closed the door. He told Krylov to explain. Krylov put the briefcase on the desk. His mind was working at maximum speed. He had one chance to survive this. One chance to complete the mission. It was a desperate gamble, but it was the only play he had left. He said he was not who his identification badge claimed. He was an aeronautical engineer who had been studying the F-15 fuel system because his country was experiencing fatal accidents with a similar aircraft design. He said the flaw was in how fuel pumps handled negative G forces. When an aircraft pushed into a dive, fuel sloshed forward in the tanks and uncovered the pump intakes. The engines lost power. Pilots died. The F-15 had solved this problem using a computer-controlled pump system that maintained fuel pressure regardless of aircraft attitude. His country needed that technology. The Major asked which country. Krylov did not answer. The Major asked if Krylov was Soviet. Krylov still did not answer. The Major said it did not matter. The aircraft had been compromised. Krylov was under arrest. The Iranian authorities would handle the interrogation. He reached for the door. Krylov said he had photographed the entire fuel system. He had the technical data the Soviets needed. If the Major arrested him now, Soviet engineers would use that data to fix their aircraft. But if the Major let him walk out of here, Krylov would destroy the film. He would return to Moscow and tell his handlers the mission failed. The Americans would have time to change the F-15 design before the Soviets could copy it. The Major turned around. He asked why Krylov would do that. Krylov said because he was an engineer, not a spy. He did not want to steal American technology. He wanted to save pilots. His pilots. American pilots. Any pilots. The flaw was killing people, and he had spent 6 years trying to fix it, and he could not. And now he had found the solution, and he was being arrested before he could use it to save lives. The Major stood in the doorway and looked at Krylov for a long time. Finally, he asked how many pilots had died. Krylov said 47 in 6 years. The Major asked what aircraft. Krylov said MiG-25 Foxbat. The Major nodded slowly. He said he had read the intelligence reports on Viktor Belenko's defection. He said the reports mentioned that the MiG-25 had operational limitations, but no one had identified the specific cause. Krylov said the cause was fuel starvation during negative G flight. The MiG-25 fuel system was primitive. Mechanical pumps. No computers. No sensors. When the fuel sloshed forward, the engines flamed out. Sometimes pilots could restart them. Sometimes they could not. The problem had been classified. Families were told their sons and husbands died in training accidents. But Krylov knew the truth. He had designed part of the system. He had attended the accident investigations. He had read the classified reports that listed every death by date and location and cause. He had memorized the names because someone needed to remember them. The Major asked if fixing the fuel system would prevent future deaths. Krylov said yes. The Major asked if the Soviets would use the stolen F-15 technology for offensive military purposes. Krylov said possibly, but that was not his decision to make. He was just an engineer trying to keep pilots alive. The major walked to the window and looked out at the F-15 sitting on the tarmac. He said his younger brother was a Navy pilot, flying F-14 Tomcats off the USS Enterprise. He said he understood what it meant to worry about someone you loved dying in an aircraft accident. Then he turned around and asked Krylov if he was telling the truth about destroying the film. Krylov opened the briefcase. Inside were the camera and the 12 rolls of exposed film. He pulled out one roll, opened the canister, and pulled the film out into the light. The exposure ruined it instantly. He dropped the destroyed film on the desk. He said he would destroy the rest if the major let him leave. The major asked what Krylov would tell his handlers. Krylov said he would tell them the security was too tight. The American instructors arrived early. He was unable to complete the documentation. He would say he failed. He would probably be sent to a labor camp, but at least he would not be executed as a spy, and his family would not suffer. The major asked if Krylov understood that by destroying the film, he was ensuring more Soviet pilots would die. Krylov said yes. He understood. But he could not steal American technology even if it meant saving his own pilots. It was wrong. He had broken enough rules by coming to Tehran. He would not break this one. The major asked what Krylov would do if he returned to Moscow without the data. Krylov said he would keep trying to solve the problem using Soviet technology. Maybe he would succeed. Maybe he would not. But he would try. The major stood silent for almost a minute. Then he walked to the desk, picked up the remaining rolls of film, and said he was making a decision that would probably end his career. He said he was not going to arrest Krylov. He said he was not going to report this incident to anyone. He said Krylov was going to walk out of this office, return to wherever he came from, and disappear. But first, Krylov was going to sit down and listen. The major opened a drawer in the desk and pulled out a technical manual for the F-15. He flipped to a section labeled Fuel System Control. He said he was violating about 15 different security regulations by doing this, but if it would save even one pilot's life, it was worth it. He showed Krylov a schematic diagram of the fuel system. He pointed to the computer control unit. He said the system used 3 pressure sensors mounted in the fuel tanks, 2 flow rate sensors in the main feed lines, and 1 3-axis accelerometer mounted near the aircraft's center of gravity. The computer sampled all sensors at 50 times per second. When it detected negative G-forces, it immediately increased pump speed and opened bypass valves to maintain pressure. The key was the accelerometer. Without accurate G-force data, the system could not anticipate fuel slosh. The major wrote down the part number for the accelerometer. He wrote down the specifications. He wrote down the operating parameters. He tore the page out of his notebook and handed it to Krylov. He said this was the critical component. If Soviet engineers could build or acquire an equivalent accelerometer and integrate it with computer-controlled fuel pumps, they could solve the MiG-25 problem. Krylov stared at the paper. He asked why the major was doing this. The major said because he had seen too many accident reports, because he had attended too many funerals, because pilots should not die from engineering flaws that could be fixed. He said nationality did not matter when it came to saving lives. Then he handed Krylov the rolls of undeveloped film and told him to get out of Tehran before someone less sympathetic asked questions. Krylov left the maintenance office in a daze. He walked across the flight line toward the perimeter gate. The guards checked his identification and waved him through. The car that had brought him that morning was waiting outside. He got in without speaking. They drove back to the apartment in central Tehran. When he arrived, the man in the dark suit was waiting. He asked if the mission was complete. Krylov said yes. He had obtained the critical data. The man asked for the film. Krylov handed over 11 rolls. He had destroyed 1 roll in front of the American major and kept 1 roll in his pocket as proof of what he had photographed. The man examined the film canisters and said Krylov had done well. A flight back to Moscow was scheduled for the next morning. Krylov should rest. Krylov nodded. He went into the small bedroom, closed the door, and sat on the edge of the bed. His hands were still shaking. He pulled out the page from the American major's notebook and read it again. Part numbers, specifications, technical parameters. This was the key to solving a problem that had killed 47 pilots and would kill more unless it was fixed. But he had obtained it through an act of mercy from an enemy officer, not through espionage. He wondered what that meant. He wondered if anyone would believe him when he wrote his report. He wondered if it mattered. The information was real. The solution was real. The lives that would be saved were real. He folded the paper carefully and put it in his briefcase next to his notebook, full of technical calculations. Then he lay down on the bed without removing his boots and closed his eyes. At 8 m.m. the next morning, Krylov boarded an Aeroflot flight to Moscow. The man in the dark suit was not there to see him off. Instead, 2 different men in suits escorted him through the airport and onto the aircraft. They did not speak to him. He sat alone in the rear of the passenger cabin, his briefcase on his lap, and watched Tehran disappear below the clouds. The flight took 4 hours. When the aircraft landed at Sheremetyevo, Krylov was met at the gate by a KGB officer who drove him directly to Dzerzhinsky Square. He was taken to an interrogation room on the 3rd floor and told to wait. He waited for 2 hours. Then 3 men entered the room. One of them was the man in the civilian suit who had attended the briefing with General Kutakov. Another was a KGB colonel he did not recognize. The third was a technical specialist from the Soviet Ministry of Aviation Industry. They asked Krylov to describe everything that had happened in Tehran. Krylov told them. He described the F-15. He described the fuel system. He described the computer control unit and the accelerometer. He showed them his notes and the page from the American major's notebook. The technical specialist asked if Krylov was certain the information was accurate. Krylov said yes. He had seen the system with his own eyes. He had photographed it. He had traced the wiring. And an American officer had voluntarily provided the critical specifications because he believed it would save pilots' lives. The KGB colonel asked why an American officer would help a Soviet spy. Krylov said he did not think the major viewed him as a spy. He thought the major viewed him as another engineer trying to solve a safety problem. The colonel said that was naive. The technical specialist said it did not matter why the information was provided. What mattered was whether it was useful. He asked Krylov how long it would take to design a similar system for the MiG-25. Krylov said 6 months if they could obtain the correct accelerometer. The specialist asked where they could obtain it. Krylov said he did not know. That was not his area of responsibility. The meeting lasted 3 hours. At the end, the KGB colonel told Krylov he would be debriefed again in 1 week. Until then, he was not to discuss the Tehran operation with anyone, including his family. He was to return to his normal duties at the Mikoyan Design Bureau and behave as if nothing had happened. Krylov asked if the information would be used to fix the MiG-25. The colonel said that decision would be made at a higher level. Krylov was dismissed. He took the metro home. His wife was in the kitchen preparing dinner. She asked him how his business trip had been. He said it was fine, routine inspections, nothing interesting. She asked where he had gone. He said he could not tell her. She looked at him with concern, but did not press. They ate dinner in silence. After dinner, Krylov went to his study and tried to work on routine design calculations, but could not concentrate. His mind kept returning to Tehran, to the American major, standing in the doorway of the maintenance office, to the question the major had asked. "Why would you destroy the film?" "Because it was the right thing to do," Krylov had said. But was it? 47 pilots were dead. More would die unless the fuel system was fixed. He had stolen American technology to save Soviet lives. Was that espionage or engineering? Was there a difference? He did not know. At midnight, he gave up trying to work and went to bed. Sleep did not come easily. On October 12, 1976, 16 days after returning from Tehran, Anatoly Krylov was summoned to a meeting at the Ministry of Aviation Industry. The building was a massive gray structure on Smolenskaya Square, 10 stories of Soviet brutalist architecture that housed the bureaucrats who controlled every aspect of aircraft production in the USSR. Krylov had been there dozens of times over the years, always to present technical reports or attend design reviews. This meeting was different. He was escorted by a KGB officer directly to the office of Deputy Minister Pyotr Dementiev. Dementiev was 71 years old and had run Soviet aviation production since 1953. He reported directly to the Central Committee. He had the authority to approve or kill any aircraft program in the country. He was not a man who tolerated failure. Krylov sat in a leather chair across from Dementiev's desk and waited. The deputy minister was reading a file. After 2 minutes, he closed the file and looked at Krylov. He asked if the information obtained in Tehran was sufficient to solve the MiG-25 fuel starvation problem. Krylov said yes, but with qualifications. Dementiev asked what qualifications. Krylov said the solution required a 3-axis accelerometer with specific performance characteristics that Soviet industry did not currently manufacture. It also required a digital computer capable of sampling multiple sensors at 50 Hz and controlling electromechanical valves in real time. Soviet fighters used analog computers. The technology gap was significant. Dementiev leaned back in his chair. He asked how long it would take to develop the required components domestically. Krylov said 2 years for the accelerometer, possibly longer for the computer. The Soviet electronics industry was focused on military applications like missile guidance and radar. Adapting that technology for aircraft fuel systems would require approval from multiple ministries and design bureaus. The bureaucratic process alone could take 6 months. Dementiev asked if there was a faster option. Krylov said they could attempt to acquire the components through foreign channels. Several Western companies manufactured suitable accelerometers for commercial aviation. The computer could be built using imported microprocessors. But that would require hard currency and approval from the Ministry of Foreign Trade. It would also expose the operation to potential Western intelligence scrutiny. Dementiev was silent for a moment. Then he asked how many more pilots would die if the fix was delayed by 2 years. Krylov did the calculation in his head. The MiG-25 fleet consisted of approximately 400 aircraft, Based on accident rates from 1970 to 1976, the fuel starvation flaw caused roughly 8 deaths per year. 2 years would mean 16 more dead pilots. Dementiev asked if Krylov was certain of those numbers. Krylov said they were conservative estimates based on classified accident data. The actual number could be higher. Dementiev picked up a telephone and made a call. He spoke for 3 minutes, mostly listening. When he hung up, he told Krylov that a decision had been made at the highest level. The MiG-25 fuel system modification would proceed immediately, using whatever means necessary to acquire the required components. Krylov was assigned as chief engineer for the project. He would report directly to Dementiev. He had 6 months to complete the design and 3 months to produce a working prototype. Failure was not acceptable. Krylov left the Ministry of Aviation Industry with a signed authorization letter that gave him unprecedented authority to requisition resources, bypass normal procurement channels, and access classified technical libraries across the Soviet defense industry. He also left with a crushing sense of pressure. 6 months to design a system that would take American engineers 2 years to develop. 3 months to build a prototype that would require testing and validation before it could be installed in operational aircraft. And all of it dependent on acquiring foreign technology through channels he did not control. He returned to the Mikoyan Design Bureau and assembled a team. 12 engineers, 3 computer specialists, 2 hydraulics experts, 1 electronics technician. He briefed them on the problem without mentioning Tehran or the F-15. He told them they were designing an advanced fuel management system to eliminate negative G fuel starvation in the MiG-25. He showed them the specifications from the American Major's notebook without explaining where they came from. He gave them 2 weeks to produce preliminary designs. Then he went to his office, closed the door, and started making telephone calls. The first call was to the Central Aerohydrodynamic Institute, TSAGI, the premier Soviet research facility for aviation technology. Krylov spoke to an old colleague who specialized in inertial sensors. He asked if TSAGI had access to any 3-axis accelerometers with the required specifications. The colleague said no, but he knew of a French company, SFIM, that manufactured similar devices for commercial aircraft autopilot systems. Krylov asked if it was possible to acquire one. The colleague said possibly, but it would require authorization from the State Committee for Science and Technology and approval from the Ministry of Foreign Trade. The process normally took 6 months. Krylov said he had authorization from the Deputy Minister of Aviation Industry and needed the device in 4 weeks. The colleague laughed and said that was impossible. Krylov read him the authorization number from Dementiev's letter. The colleague stopped laughing. He said he would make inquiries. Krylov's second call was to the Institute of Control Sciences, which developed computer systems for Soviet spacecraft and ballistic missiles. He spoke to a department head who specialized in real-time control algorithms. He explained the fuel system problem and asked if existing Soviet computer technology could handle the required processing speed. The department head said yes, but it would require a custom design using military-grade components. The development time would be at least 1 year. Krylov said he had 6 months. The department head said that was unrealistic. Krylov asked what would be required to make it realistic. The department head said unlimited budget, priority access to component fabrication facilities, and exemption from normal testing protocols. Krylov said he had all three. The department head asked who had authorized this project. Krylov gave him Dementiev's direct telephone number. The department head said he would call back within 24 hours. For the next 3 weeks, Krylov worked 18-hour days. He slept in his office. His wife brought him food. He saw his daughter twice. The design team produced 4 different concepts for the fuel management system. Krylov evaluated each one against the F-15 specifications. 2 concepts were eliminated because they required components that did not exist in the Soviet supply chain. A third was eliminated because the response time was too slow. The 4th concept was viable but required significant modifications to the MiG-25 fuel tank structure. Krylov calculated the weight penalty. 8 kilograms. Acceptable. He calculated the installation time. 40 hours per aircraft. Also acceptable. He presented the design to Dementiev on November 3, 1976. Dementiev approved it with 1 modification. He wanted the system to be retrofittable to existing MiG-25 aircraft without requiring factory return. Krylov said that would require a modular design that could be installed at field maintenance facilities. It would add complexity, but was technically feasible. Dementiev said, "Make it work." Krylov went back to the design team. On November 18th, the accelerometer arrived from France. It had been purchased through a shell company registered in Finland, shipped to East Germany, and transported to Moscow by diplomatic pouch. The total cost was 47,000 rubles, approximately 6 times Krylov's annual salary. The device was smaller than he expected. A machined aluminum cylinder, 8 centimeters long and 3 centimeters in diameter, weighing 140 grams. Inside were 3 miniature pendulum sensors mounted on orthogonal axes, each connected to a precision potentiometer that converted mechanical displacement into electrical voltage. The output signals were accurate to within 1% across a range of plus or minus 10 G-forces. It was a masterpiece of Western precision manufacturing. Krylov handed it to his electronics technician and told him to reverse engineer it. The technician asked how long he had. Krylov said 2 weeks. The technician said he would need access to precision machine tools and clean room facilities. Krylov made more telephone calls. 3 days later, the technician was working in a classified facility at the Moscow Aviation Institute with equipment normally reserved for spacecraft components. He produced detailed drawings of every part in the accelerometer. He identified the materials. He documented the assembly procedures. He delivered the package to Krylov on November 30th. Krylov sent the drawings to 3 different factories with instructions to produce 10 units each using the best available Soviet equivalents for the Western materials. He knew the Soviet versions would not be as precise as the French original. The manufacturing tolerances would be looser. The output signals would be noisier. But if he could achieve accuracy within 5% instead of 1%, the system would still work. It would just require more sophisticated signal processing in the computer. The computer was a bigger problem. Soviet military computers in 1976 were large, power-hungry, and slow by Western standards. The latest model used in MiG aircraft, the Orbiter 10, weighed 18 kilograms and required 200 watts of power to operate. It could perform approximately 20,000 calculations per second, which sounded impressive until you realized that the F-15's fuel control computer performed 200,000 calculations per second and weighed less than 3 kilograms. The technology gap was enormous. Krylov met with the team from the Institute of Control Sciences on December 4th. They presented 2 options. Option 1 was to use an existing Orbita 10 computer and write highly optimized software that could barely meet the performance requirements. This would work, but would leave no margin for error. If the accelerometer signals were noisy, if the valve response times were slower than expected, if anything went wrong, the system would fail. Option 2 was to design a new computer from scratch using imported Western microprocessors. This would provide much better performance, but would take at least 9 months and would make the system dependent on foreign components that might not be available in the future. Krylov asked if there was a third option. The lead engineer said they could try to build a hybrid system using Soviet processors, augmented with imported memory chips, and analog to digital converters. This would reduce the dependency on Western components while improving performance. It might be possible to complete the design in 6 months. Krylov said, "Do it." By January 1977, the project was consuming every minute of Krylov's life. He had not been home for more than a few hours at a time in 2 months. His wife was worried. His daughter called him at the office and said he looked terrible and needed to rest. He said he would rest when the prototype was finished. On January 19th, the first Soviet-made accelerometer came back from the factory. Krylov tested it personally, using a centrifuge at TSAGI. The output signals were noisy, just as he had predicted. The accuracy was approximately 4%, better than he had hoped. He declared it acceptable and ordered the factory to produce 20 more units. On February 8th, the prototype computer arrived from the Institute of Control Sciences. It weighed 8 kilograms, nearly 3 times the weight of the F-15 system, but it met the performance specifications. Krylov integrated it with the accelerometer, the fuel pumps, and the control valves in a test rig that simulated the MiG-25 fuel system. He ran the first test on February 12th. The system worked. When he commanded the test rig to simulate negative 3G forces, the computer detected the acceleration, increased pump speed, and maintained fuel pressure. He ran the test 50 more times with different G-force profiles. The system worked every time. On February 15th, he reported to Dementiev that the prototype was ready for flight testing. The first flight test took place on March 3, 1977, at the Akhtubinsk Test Center, a classified facility in the Astrakhan region used for evaluating new aircraft and weapons. A MiG-25 interceptor had been modified with the new fuel management system. The test pilot was a colonel named Alexander Bezhevets, one of the most experienced pilots in the Soviet Air Force. Krylov briefed him on the system before the flight. He explained that the computer would automatically adjust fuel flow during negative G maneuvers. The pilot's only job was to fly the aircraft normally and report any unusual behavior. Bezhevets asked what would happen if the system failed. Krylov said the aircraft would revert to the original fuel system and the pilot would experience the same engine surge problems that had killed 47 pilots over the past 6 years. Bezhevets asked if Krylov was confident the system would not fail. Krylov said he was 95% confident. Bezhevets said that was good enough for him. He climbed into the cockpit. Krylov watched from the control tower. The MiG-25 took off at 10 in the morning and climbed to 12,000 meters. For the first 20 minutes, Bezhevets flew standard maneuvers, turns, climbs, descents, everything normal. Then he pushed the nose down into a steep dive and pulled -2 G forces. Krylov held his breath. The engines maintained power. No surge, no flameout. Bezhevets reported over the radio that the aircraft was performing normally. He repeated the maneuver 5 more times with progressively higher negative G forces. Every time, the system worked. He landed after 45 minutes. When he climbed out of the cockpit, he walked directly to Krylov and shook his hand. He said the fuel system modification was the most important safety improvement he had seen in his 20-year flying career. Krylov submitted his final report to Dementiev on March 10, 1977. The report documented the entire project from the Tehran operation to the successful flight test. It included technical drawings, test data, cost estimates, and a production schedule. Krylov recommended immediate implementation of the fuel management system across the entire MiG-25 fleet. He estimated the retrofit program would take 18 months and cost approximately 200 million rubles. He also recommended that the system be incorporated into future aircraft designs, including the MiG-31 interceptor that was currently under development. Dementiev read the report and called Krylov to his office. He said the Central Committee had approved the retrofit program. Production would begin immediately. Then he said something that surprised Krylov. He said the entire project, from the Tehran operation to the final flight test, would be classified at the highest level. No public acknowledgement, no awards, no recognition. The official story would be that Soviet engineers had independently developed an advanced fuel management system through routine research and development. The Tehran operation never happened. The American major who provided critical technical information never existed. The 47 dead pilots would remain a state secret. Krylov asked why. Dementiev said because admitting that Soviet engineers had needed to steal American technology to fix a fatal flaw in Soviet aircraft would be politically unacceptable. It would undermine confidence in the Soviet aviation industry. It would embarrass the Communist Party. It would give the West propaganda ammunition. Better to pretend it never happened. Krylov sat in silence. Then he asked what would happen to him. Dementiev said nothing would happen to him. He would continue his work at the Mikoyan Design Bureau. He would be given a modest salary increase and a larger apartment. But he would never speak about this project to anyone, not his colleagues, not his family, not even other engineers who worked on the system. The Tehran operation was buried. Forever. Krylov returned to his office at the Mikoyan Design Bureau and sat at his desk for a long time without moving. Through his window he could see the Moscow skyline, apartment buildings, factories, monuments to Soviet achievement. He thought about the 47 pilots whose deaths had driven this entire project. He thought about the American major in Tehran who had violated security regulations to help save Soviet lives. He thought about the engineers on his team who had worked impossible hours to turn stolen technology into a functioning system. He thought about the hundreds of future pilots who would never know that their lives had been saved by an act of espionage and an act of mercy. None of it would be remembered. None of it would be acknowledged. The system would be installed. The pilots would be saved. And everyone who made it happen would fade into obscurity. That was how the Soviet system worked. Results mattered. Recognition did not. Krylov opened his desk drawer and pulled out the page from the American major's notebook. The part numbers, the specifications, the handwritten notes that had made everything possible. He had kept it hidden for 5 months, against regulations, because it felt wrong to destroy it. Now he understood why. It was the only proof that what happened in Tehran was real. He folded the paper carefully and put it back in the drawer. Someday, he thought. Someone would want to know this story. Someday, when the Soviet Union no longer cared about propaganda and embarrassment, someone would open the classified files and discover what really happened. Until then, the paper would stay in his desk drawer, a secret memorial to 47 dead pilots and one American officer who believed that saving lives was more important than nationalism. The first production fuel management system was installed in a MiG-25P interceptor at the Gorky Aircraft Factory on May 23, 1977. The installation took 38 hours, 2 hours less than Krylov had estimated. The aircraft was flight tested for 6 hours over the next 3 days, during which the pilot performed every negative G maneuver in the training manual. The system worked flawlessly. On May 27th, Deputy Minister Dementiev authorized full-scale production. The modification program was designated Project 25M and classified at the highest security level. Only 12 people in the entire Soviet Union knew the full story of where the technology came from. Krylov was one of them. He was also the only one who seemed to care about keeping count of the lives being saved. He kept a notebook in his desk drawer, next to the page from the American major. In the notebook, he recorded every MiG-25 that received the modification. Aircraft number, installation date, base location. By the end of 1977, 83 aircraft had been modified. By the end of 1978, 201 aircraft. By the end of 1979, the entire operational fleet of 387 MiG-25 interceptors had been retrofitted with the new fuel management system. The program was completed 6 months ahead of schedule and 15 million rubles under budget. Dementiev called it the most successful aircraft modification program in Soviet history. He also made sure no one outside the program ever heard about it. Krylov continued tracking accident statistics. This was not part of his official duties, but he had access to classified accident reports through his position at the Mikoyan Design Bureau. Before the modification, the MiG-25 had experienced an average of 8.2 fuel starvation accidents per year between 1970 and 1976. That was 47 accidents total, all fatal. After the modification was completed in 1979, the number dropped to 0. Not one single fuel starvation accident occurred in a modified MiG-25 between 1979 and 1991, when the Soviet Union collapsed. Krylov did the mathematics. The MiG-25 remained in operational service with the Soviet Air Force and later the Russian Air Force until 1993. That was 14 years of accident-free operations across a fleet of nearly 400 aircraft. Based on pre-modification accident rates, approximately 115 pilots would have died from fuel starvation during that period. They did not die because of a system designed in 6 months, built from a combination of stolen American specifications and Soviet engineering improvisation, and installed by maintenance crews who had no idea they were working on the most important safety modification in Soviet aviation history. Krylov wrote the number in his notebook. 115 lives saved. Then he did another calculation. The MiG-25 was also operated by Soviet allies. Algeria received 20 aircraft. Syria received 30. Libya received 60. India received 10. Iraq received 45. Most of these export aircraft were older models that did not initially receive the fuel management modification. But between 1980 and 1985, the Soviet Union quietly offered retrofit kits to Allied nations as part of standard maintenance packages. Not all countries accepted, but most did. Krylov estimated that approximately 120 export aircraft received the modification. Based on typical accident rates for export operations, which were higher than Soviet rates due to less rigorous training and maintenance, The modification probably saved another 85 pilots over the operational life of those aircraft. Total lives saved, 200, give or take 20, depending on assumptions about accident rates and operational tempo. Krylov never shared these calculations with anyone. There was no one to share them with. The project was classified. His colleagues at the Mikoyan Design Bureau knew he had worked on a fuel system modification, but they did not know where the design came from or why it had been developed so urgently. His wife knew he had traveled somewhere in 1976 but did not know where or why. His daughter knew he had worked on something important but did not ask questions. That was how you survived in the Soviet system. You did your job, you kept secrets, you did not ask uncomfortable questions, and you accepted that recognition was less important than results. Krylov accepted all of this, but he could not accept the idea that 200 pilots would live instead of die, and no one would ever know why. So he kept his notebook. He updated it every year with new accident statistics. He calculated survival rates. He estimated the number of children who would grow up with fathers, the number of wives who would not become widows, the number of mothers who would not bury sons. The numbers were abstract, but they made the work feel real. They made it feel like something more than espionage and bureaucracy and classified files that no one would ever read. In 1982, Krylov was assigned to work on the MiG-31, the next-generation interceptor that would replace the MiG-25. The MiG-31 incorporated the fuel management system from the beginning, built into the design rather than retrofitted. No one on the design team asked where the original concept came from. They simply accepted it as proven Soviet technology. Krylov did not correct them. He supervised the integration, ensured the system met performance specifications, and signed off on the final design. The MiG-31 entered service in 1983. It never experienced a fuel starvation accident in 40 years of operations. Krylov considered that his greatest professional achievement, not because the aircraft was successful, but because pilots flew it without ever knowing that someone had risked everything to make sure they would not die from a preventable engineering flaw. In 1985, Krylov received a promotion. He was named Deputy Chief Engineer at the Mikoyan Design Bureau, responsible for all flight control systems across the entire product line. It was one of the most important technical positions in Soviet aviation. The promotion came with a salary increase, a larger apartment, and access to a special store where high-ranking officials could purchase Western goods not available to ordinary citizens. Krylov accepted the promotion and used the salary increase to buy his daughter a piano. He did not tell her why he could suddenly afford it. In 1987, Mikhail Gorbachev announced glasnost and perestroika, openness and restructuring. The Soviet system began to crack. State secrets were revealed. Archives were opened. Journalists investigated previously forbidden topics. Krylov wondered if anyone would investigate Project 25M. No one did. The fuel management modification was too technical, too obscure, too buried in layers of classification. There were bigger secrets being revealed. Political purges, famines, massacres. The deaths of 47 MiG-25 pilots between 1970 and 1976 did not make the list of historical injustices that needed to be addressed. In 1991, the Soviet Union collapsed. The KGB archives were partially opened. Foreign journalists descended on Moscow looking for Cold War stories. Krylov was approached once by an American reporter who was writing about Soviet aviation technology. The reporter asked if Krylov had worked on the MiG-25. Krylov said yes. The reporter asked if it was true that the MiG-25 had significant design flaws. Krylov said all aircraft have design flaws. The question is whether you fix them or hide them. The reporter asked if the Soviets had ever stolen Western technology to fix design flaws. Krylov said he could not comment on classified projects. The reporter thanked him and left. The article that was eventually published mentioned the MiG-25's limitations, but said nothing about fuel starvation or the Tehran operation. Krylov was not surprised. The story was too complicated, too technical, too difficult to verify. It was easier to write about defectors and spy satellites and nuclear weapons. Those stories had clear villains and heroes. The story of 200 pilots who did not die had no drama. It was just engineering. In 1994, Krylov retired from the Mikoyan Design Bureau after 48 years of service. He was 69 years old. He had worked on 8 different aircraft types, from the MiG-19 to the MiG-31. He held 37 patents for flight control systems. He had trained 3 generations of engineers. His retirement ceremony was attended by 120 people, including the current chief designer and 2 deputy ministers. He was awarded the Order of the Red Banner of Labor for distinguished service to Soviet aviation. The citation mentioned his contributions to fighter aircraft development, but did not mention Project 25M. After the ceremony, Krylov went home to the apartment he had lived in since 1978. His wife had died 2 years earlier from cancer. His daughter lived in Germany with her husband and 2 children. Krylov spent his retirement reading, gardening, and occasionally consulting for the Design Bureau on technical problems. He lived quietly. He did not give interviews. He did not write memoirs. He kept his notebook in the desk drawer, along with the page from the American Major's notebook. Both documents yellowed with age. The ink faded, but the numbers remained legible. 47 dead pilots, 200 saved pilots, 1 American officer who chose to help instead of arrest, 1 Soviet engineer who chose to fix a problem instead of hide it. On March 15, 2003, Anatoly Sergeyevich Krylov died of heart failure at his apartment in Moscow. He was 78 years old. His daughter flew from Germany for the funeral. 17 people attended, mostly former colleagues from the Design Bureau. There was no obituary in Pravda. There was no state funeral. There was no mention of his role in Project 25M because Project 25M was still officially classified, even though the Soviet Union no longer existed, and most of the people who remembered it were dead. After the funeral, Krylov's daughter cleaned out his apartment. She found the notebook in the desk drawer. She read it, but the technical details meant nothing to her. She found the page from the American Major's notebook. She did not recognize what it was. She packed both documents in a box with her father's other papers and took them back to Germany. The box sat in her basement for 18 years. In 2021, a Russian aviation historian named Dmitry Volkov was researching the development history of the MiG-25 for a book. He submitted a Freedom of Information request to the Russian Defense Ministry, asking for access to declassified accident reports from the 1970s and 1980s. To his surprise, the request was approved. The Russian government was more open than the Soviet government had been, especially about events from 50 years ago that no longer seemed politically sensitive. Volkov spent 6 months reading accident reports. He noticed a pattern. Between 1970 and 1976, the MiG-25 had experienced numerous fatal accidents attributed to fuel starvation during negative G maneuvers. After 1979, those accidents stopped completely. The change was abrupt and absolute. Volkov knew that kind of pattern meant someone had fixed something. He started looking for modification reports He found references to Project 25M, but the details were still classified. He found the names of engineers who had worked on the project. Most were dead. One name appeared repeatedly in the documents: Anatoly Krylov. Volkov searched for information about Krylov. He found an obituary from 2003. He found a short biographical entry in a technical encyclopedia. He found a list of patents. Then he found Krylov's daughter through a genealogy website. He sent her an email asking if her father had ever mentioned Project 25M. She responded 3 weeks later. She said her father had never talked about his work, but she had found some papers in his desk after he died. She did not know if they were important. She scanned them and sent them to Volkov as attachments. When Volkov opened the files, he found 2 documents. One was a notebook filled with aircraft registration numbers, dates, and accident statistics. The other was a page torn from a notebook with handwritten technical specifications in English. Volkov recognized immediately what he was looking at. The notebook was a record of the Project 25M retrofit program. The handwritten page was specifications for an F-15 Eagle fuel management component. But how had a Soviet engineer in 1976 obtained specifications for an F-15 component? Volkov spent 2 months researching. He found references in declassified KGB files to a covert operation in Tehran in September 1976. He found diplomatic cables mentioning the arrival of American F-15 aircraft in Iran for evaluation. He found records indicating that Anatoly Krylov had traveled to Tehran in September 1976 on a classified mission. He pieced together the story: the Tehran operation, the confrontation with the American major, the decision to provide technical assistance despite the Cold War, the 6-month design program, the retrofit of 387 Soviet aircraft and 120 export aircraft, the 200 lives saved. Volkov wrote everything into a 15,000-word article and submitted it to a Russian aviation journal. The article was published in November 2024 under the title, "The Engineer Who Saved 200 Pilots: The Untold Story of MiG-25 Project 25M and the American Officer Who Helped." The article received almost no attention. A few hundred people read it. Most of them were aviation enthusiasts or retired engineers. No major newspaper picked up the story. No documentary filmmaker expressed interest. The story was too old, too technical, too lacking in political controversy. But one person who read the article was Major Robert Hendricks, United States Air Force, retired. Hendricks was 72 years old and living in Arizona. He had served as a technical advisor for the F-15 program in the 1970s. He had been stationed in Iran in September 1976 to oversee the delivery of demonstration aircraft to the Iranian Air Force. He remembered an incident at Mehrabad Air Base where he had encountered a man claiming to be an Iranian technician who was actually a Soviet engineer gathering intelligence. Hendricks had made a decision that day that had haunted him for 48 years. He had violated security regulations. He had provided classified technical information to a foreign national. He had let a spy walk away. He had never told anyone because he knew it would end his career and possibly result in criminal charges. Now he was reading an article that said his decision had saved 200 lives. Hendricks sat in his living room in Arizona and cried. Then he wrote a letter to the Russian aviation journal confirming every detail of Volkov's article. He explained why he had helped Krylov. He said that some decisions transcend politics and nationality. He said that engineers should help other engineers solve problems that kill people, regardless of whose uniform they wear. He said he had never regretted his decision, even when he thought no one would ever know about it. The journal published Hendricks' letter in its January 2025 issue. This time, The story received slightly more attention. A few American aviation websites mentioned it. A podcast about Cold War history did a 30-minute episode, but still no major media coverage. The story remained obscure, a footnote in the history of the Cold War, a technical curiosity. This is how history forgets its heroes. Not with deliberate suppression, but with indifference. The story of Anatoly Krylov and Robert Hendricks does not fit comfortable narratives. It is not about victory or defeat. It is not about good guys and bad guys. It is about two engineers who believed that saving lives was more important than following orders. It is about 47 pilots who died from a preventable flaw, and 200 pilots who lived because someone cared enough to fix it. It is about a modification program that succeeded brilliantly and was buried immediately. It is about a piece of paper torn from a notebook that sat in a desk drawer for 27 years and in a basement storage box for 18 more years before anyone realized what it meant. It is about the fact that most of the people whose lives were saved by Project 25M never knew they had been in danger and never knew they had been saved. They flew their MiG-25 interceptors, completed their missions, returned to base, and went home to their families without ever thinking about the fuel management system that kept their engines running during negative G maneuvers. That is the nature of good engineering. It works invisibly. It prevents disasters that never happen. It saves lives that are never counted. Anatoly Krylov understood this. That is why he kept his notebook. Someone needed to count. Someone needed to remember. Even if no one else ever knew.